Hello, everybody. We're going to get started here in about 3 minutes, letting everybody join in. I'm David Wells, and I'm going to be talking about serverless stuff and React and how they're amazing together. And then I think we're going to do Q&A. If you have questions throughout the presentation, leave them in the Google chat, or we're going to do a Q&A after this. So yeah, let me just double check that everything is working. Can everybody hear me okay? Say yes in the chat if you can. Everything is good in Portland. All right, awesome. Cool. All right, let's go ahead and get started. In 1 minute, let me go ahead and share my screen. Whoa, infinite loop. Okay, cool. So yeah, let's go ahead and get started. Jason, if there's any problems, just ping me on Skype and we can fix it. But yeah, cool. So, and yeah, before I start, I wanted to thank Jason for inviting me to do this. This is awesome. I love talking about this stuff. And I want to thank New Relic for hosting. You guys are awesome. But yeah, so let's get into it. So my name is David Wells. I'm a software engineer over at serverless.com. And previously I worked at MuleSoft doing UI UX stuff. And yeah, so I actually decided to change my talk to how to refactor app into Angular 1, then back into jQuery. So surprise, just kidding. I don't know if anyone's laughing at that. Anyways, yeah, no, just kidding. We're actually here, we're talking about serverless, right? So we want to basically, I'm going to toss my video up here. There we go. So yeah, we're talking about serverless today. What is it, and like basically how you can use it with your React applications to kind of build, in my opinion, the dream stack. So it's basically, and I'm going to go through this, like why I think it's a match made in heaven, and why you can build pretty sophisticated applications at a way lower cost than previously was kind of possible. And we'll dive into kind of why that is. Real quick, just some housekeeping here. So these slides are available at this bit.ly URL if you want to download them, reference them later, etc. Again, if you have a question, leave it in the chat on YouTube, or just tell Jason we're going to do the Q&A right after. Or feel free to tweet at me anytime at David Wells, or contact me on my site. Always happy to talk about this stuff with people. But yeah, so basically, like the how I got here doing like this serverless stuff, and what got me really into it was I have these life goals. These life goals of basically becoming this unicorn child. This unicorn child that can do everything on the front end and do everything on the back end in a sane way. That was kind of like a goal of mine when I set out to kind of dive into the back end world. And basically my journey kind of started way back when I was building an application using a Node server. Started getting pretty deep into the Docker world, and that quickly became pretty complex. Basically, and here's a quick example. So I don't know if you guys are familiar with Wes Boss. He's awesome. You should follow him on Twitter. But scaling servers is hard, right? When you're actually like trying to deploy a production ready application, there's quite a few things that you need to really consider if you're gonna like basically scale with the traffic that you get. Making kind of a demo app is pretty straightforward, but as you start to like get more and more traffic, it becomes more and more complex, and there's a lot more DevOps stuff that you really need to consider. But I always see Wes tweeting about his server going down. He's running stuff on his own Node server using Express. And there's nothing wrong with Express or Node servers. I'm actually going to be like showing like Node code today and how it runs in Lambda. But yeah, every time he does this, I tweet at him and say, hey Wes, when are you gonna check out serverless? But anyways, yeah. Love you, Wes. Not trying to call you out or anything. Check out Wes's courses. He has a really awesome Redux course, actually, at learnredux.com. Highly recommend it. But yeah, so some of those concerns that I was talking about when you are actually trying to like deploy your production-ready app and you're using, let's say, a Docker container with your node setup, right? So you need to think about load balancing. You need to think about security concerns. Is my server secure? Are all my dependencies, basically scanned for any potential vulnerabilities? How am I going to do monitoring? How am I going to do logging? How am I going to set up follower database instances or like slave like replicas? And then what is that going to cost me, right? So again, when you have one server that's running your database and your app, it's super easy, but it's not very resilient. So when you actually do start seeing like a production kind of load, it gets pretty complex pretty quickly. There are and kind of a thing that we've been seeing in the container space is a way to manage that. It would be with like Docker Swarm or Kubernetes, right? So that does alleviate a lot of these concerns. But yeah, so when I was really like diving into the stuff and trying to basically like battle harden my application that I was building, I looked like this kid here, where it's like, oh my gosh, I just wanted to build something cool and have as many people as possible use it. Like I really just care about putting awesome things into the world that people can use. I don't really want to kind of dive off the deep end, learning at every single piece of that. It kind of takes me away from my kind of goal of being that unicorn child. So around this time, basically, I heard about AWS Lambda. And this is typically when I ask the audience if they've heard of Lambda. I can't see you guys right now, but I'm assuming that you have. Basically, AWS Lambda is a compute service from AWS that lets you execute your code on demand. But yeah, it kind of changed the game, and I'll go into that right here. So really, at its core, what serverless is running your code on demand in a cloud of your choice. So you don't have to go with AWS. There's a lot of different providers, which I'll get into. But these are kind of the core concepts around what a serverless like kind of model is. First of all, it's pay per execution pricing. So what that means is you only pay per milliseconds that your code actually runs. So in comparison, if you're running a Docker container or something on DigitalOcean or in a Droplet or what have you, you're paying hourly for that box. And even like the cheapest box, kind of like around like $8 a month or something. A lot of times, maybe that might be sitting idle or there's unused kind of resources there. That's really one of the considerations that you need to look into when going with servers. Whereas Lambda only runs the code when you only get charged when the code actually runs. So if no one uses your application, you literally pay $0. If a lot of people use your application, it auto scales for you. So whatever the compute provider is, they will manage that scaling for you. You never pay for the idle servers. There's this concept of basically, it's more of an event-driven kind of workflow. And we'll get into what that means in a little bit. And then there's also this kind of concept of leveraging third-party services for things that aren't necessarily your company's core competencies. So, for example, it doesn't really make sense to roll your own auth service if there's something like Auth0 or AWS Cognito. It doesn't really make sense for you to set up your own transactional mailing service these days with things like Mandrill and SendGrid and all those. Same with like text messages with Twilio, etc. So really, it's at its core, it's about focusing on like what is your app doing and what value is it like giving to the user. Focus on that, not on the I would say tedious kind of busy work. That stuff's important, but you don't need to really worry about that today. And like I mentioned, so you don't have to go with AWS. Today, I'm focusing on AWS and Lambda. It's kind of my provider of choice. But all of the major cloud providers, Microsoft, Google, IBM, all have functions as a service offerings. As well as Auth0 has one. Oracle just recently announced one. You can also run functions as a service inside of Kubernetes. Arguably, you could argue, there's debate on whether or not that's serverless because you're managing that Kubernetes cluster. It's still cool though, and it still like carries along a lot of these concepts that I'm talking about, like event-driven workflows and what have you. So like, real quick, what can you do with it? There are like a ton of different use cases. Not going to go into all of these. We have a repo down at the bottom there of serverless examples. But I would say you could pretty much do anything you do on your node server today, with the caveat that you cannot run anything that is longer than 5 minutes. So that's a limit right now on the providers, where if your function takes more than 5 minutes to execute, it does not belong in a serverless function. So if you are doing any like kind of heavy machine learning stuff or what have you, that's not really suited for kind of the serverless world. That said, there are kind of ways around that. Yeah, there are some ways around that. You could basically have like a serverless function, spin up an EC2 instance, run your long running job, and then spin back down and respond with that. So we are seeing people kind of work around this when they're building out their serverless architectures. But yeah, so I have a bunch of other talks on like these use cases. I think it's called Real World Serverless or something like that. I'll toss a link in the meetup chat. But yeah, so anyways, moving on. Today, like what I want to show you guys is actually a serverless kind of service or application that is it's open source. The repo's down there at the bottom. We use this for managing all of our form submissions on our website and across our various properties. So this has a serverless backend and a React front end. That's all in that repo there. So let's actually take a look at it. So there is some context. Cool. So this is our serverless forms application. Basically, it is on the front end side. This is just using Create React App right now. I can't tell you how much that changed my life when that came out. I used to do workshops teaching React, and the first like 2 days we talk about Webpack config. No more. Use Create React App if you don't already, and then eject when you need to. This is not ejected yet. So, but anyways, we're using React Router for routing through the application. Redux for state management, Axios just to make the AJAX calls to our backend, and then the user authentication, we're using Auth0. And then this, my kind of preferred host of choice is Netlify. Super awesome. I'll get into why they're awesome in a little bit. And then like the backend is basically, this is the architecture. Let me zoom in here. So we're running a number of different Lambda functions, and I'll show you guys what this code looks like in a little bit. This is just kind of the high level architecture. So we have a number of different Lambda functions in our service, and we're going through AWS API Gateway to actually access those functions. Those functions are fetching data from 2 DynamoDB tables. And then, so like, there's one side where it's like, here's where we're actually collecting the form submissions from different various web properties. Obviously, there's no authentication needed there because anyone can, contact us today, etc. But then on the backside, and I'll log in and show you guys what the app looks like inside. But basically, that data, when someone actually submits a form, that needs to be obviously protected. So that's actually protected by a custom authorizer. And I'll go into details on that as well. But cool. So that is kind of the high level overview of what the actual application is. I didn't super style this, so don't don't judge it too much. But the code's all there, and it's using vanilla CSS right now. I'd use post CSS if I ejected. So I'm going to go ahead and log in, and I'm OAuthing via GitHub through Auth0, and now it's loading my forms. Cool. That just made a request to our backend. That just pinged a Lambda function. That Lambda function is the basically like pull back the form information, and then if I go into an actual form, it pulls back all of the different kind of submissions there. So that is the kind of what it does in a nutshell. This is calling out to a couple of different REST API endpoints, which I'll show you guys in a little bit here, as well as like simulating how. So what Auth0 uses JSON Web Tokens as the authorization mechanism. So inside of my local storage here, we have a JWT. That JWT is right here. This actually is what's being sent when I'm like jumping into like a form view. That this is being sent along with the authorization header, and that's what the custom authorizer function is actually checking. Is it valid? Is this a real user? And are they an admin? So if any of you are, since we're broadcasting this to everyone in Portland and to the internet, you might have tried to log in and try this. If you do that, what it's going to do is basically tell you you are not a authorized user. And I'll show you guys how that works as well, but I'll just demo it real quick. So I'm logging in with our bot serverless account and this is in a different browser instance. But if I go ahead and log in, you can see, oh, you're not an admin. Please contact the admin to actually see stuff. So we're basically protecting that data with the JWTs. So that is the app. And again, if you want to like simulate this in the app, like the repo can be cloned down today and deployed. And I'll show you how that works. But yeah, so I'm just going to mangle my JWT. And then if I go back, it's saying, oh, I'm not authorized. So yeah, anyways, so that's the quick demo. Get back and do it. I already talked about these bits. So very, very, very standard React application. Backend, already talked about that. Already went through the kind of architecture. So let's actually dive into how the authorization works. So here we were in the admin UI that we just saw. When an API request is made, that JWT is sent along with a header, and it hits that custom authorizer function. There's a couple of different ways that you can do authorization with AWS. If you're using Amazon Cognito, which Amazon Cognito is basically Amazon's version of Auth0, basically, user login with Facebook, Twitter, etc., or via email. It's just the managed AWS one. You can basically use client libraries from AWS to do that. That's actually what I'm going to dive into in my next project. There are some gotchas with Auth0, and there's some benefits with AWS Cognito, but honestly, getting started and getting things up and running, Auth0 is kind of just plug and play, and you're off to the races. So what we're talking about today is actually like the custom identity provider, so like a custom authorizer function. And really what that does, I already talked about this a little bit, but from the UI, we request with the JWT token after the user is logged in. The function checks if the JWT is valid. And so you can write any custom logic you want in there, right? By the way, you don't have to use JWTs to do this. You can literally, do whatever you want in that custom authorizer function. So you could call into a database and say, oh, is this person valid, or is this the correct plain text password? Like, don't do that, but you could. That's kind of the flexibility of a custom authorizer function. And we'll look at the code here in a second. So if they are authorized, it generates an what's called an IAM policy, and that's basically the access control plane of AWS. And it says like, hey, the JWT is valid, so generate an IAM policy that lets them invoke the REST API function to like get form information or to get the form submissions. If they're not authorized, we just return unauthorized and stop right there. So in the client, it says, nope, you're not allowed. Sorry. There are a lot of benefits to using a custom authorizer. You can basically set caching at this layer. Like technically, you could have your auth logic in each one of these functions, but you don't get basically that benefit of the caching layer here. So like if I don't want to do an expensive API call every single time anybody hits one of my APIs, and I want to cache that for, let's say, 5 minutes or something, that's kind of where the custom authorizer comes in. It's also kind of, if you're writing your logic, you don't want to be spreading around your auth logic across multiple functions across your system, because if you need to update it, then you need to update it across your entire system. Whereas this is kind of like a single place that you can manage that. But yeah, cool. The other kind of benefit there is, if it's cached, you're not like kind of being charged for that invocation. But cool. Awesome. So let's talk about Auth0 for a little bit. So Auth0, super awesome, like I said. Crazy easy to get started. Let me actually log in and show you guys what it looks like. Okay. So, oops. So basically, when you log into Auth0, you simply like create a client and choose like a single page web app. And after that, you have like a client ID that you just plug into your front end application and use the Auth0 client library. And you're kind of off to the races from that point. And there's an example of that in the repository. But let me get out of hackers. Busted. Okay, I'm going to close this window. All right, so with Auth0, so like I mentioned, you create a client, you make a single page web app, super simple. That gives you a, inside of Auth0, there's this concept of tenants. So like you have a domain, so whatever your like account name is. So this is our serverless QA account, and then we have a client ID. These are the values that you would take and plug into your client-side application. And real quick, I want to show you how. So I'm an admin user on that particular application, and I'm going to show you guys how that works inside of Auth0. So like Auth0 has a lot of kind of like plugins out of the box to extend the base functionality of Auth0. Let me go ahead and 1 second log in here. So they have this authorization extension. So after you if you go into extensions and install it, it'll have this little authorization guy after that. But once you actually go into that, you can see that we can see all of our users for this particular tenant, and I can actually manage groups and roles and permissions. So there's like 3 different layers. This is vastly simpler than using AWS IAM and kind of Cognito stuff. There's not as much power under the hood, but you can still build robust applications with it. But what I have here is actually a group. Inside of this group, I have 3 of our teammates here. I guess everyone knows their email now, as well as my own. But yeah, so basically everyone in this group, they have the role of admin. So that's actually what's controlling that. And that's actually being added to the JSON Web Token when I log in. So if we actually decoded, let me go back into the application and we'll take a look at that. So serverless forms. You want to make sure you go HTTPS. If you put a custom domain on Netlify, everything works out that way. All right, so I'm going to log in again. Show you that I am indeed an admin. Cool, I'm an admin. If I look at my profile, this is actually the decoded JSON Web Token. Let me zoom in on that. So the sub is actually I logged in with GitHub, so that's my GitHub kind of user ID. That's my email. Don't spam me. And then this is actually the roles that are included in the JSON Web Token that is giving me access to this particular application. So if I actually came back in here and removed myself, so I'm going to remove David from the admins. And then if I go ahead and log out and try to log back in with the same account, it should yell at me unless I'm a different user. Yep, I'm a different user. 1 second. So inside of users, David Wells. So I have the admin role associated with this account. So I removed the wrong guy. Let me remove this guy. So I'm removing my role. So now I've revoked access to myself. I'm no longer an admin. It's a sad day. But now if I go ahead and refresh this, log in again, what we can see is, oh snap. I almost said a bad word. Yeah, so I'm not an admin anymore. So I need to contact the administrator and say, give me access again. I want to read the forms. So that's kind of in a nutshell how that works. I'm going to add myself back in as an admin user. So it fixes everything for me. But yeah, so that in a nutshell is really how the authorization works. And this is the again, you can get the slides from that link that I shared before to walk you through these steps. I believe they're also in the repository. But yeah, so you can manage roles. And then the last and kind of final step is actually the way that token gets added to your JSON Web Token when you log in. You actually set up what's called a rule inside of Auth0. They also have a new hooks functionality. It does similar things. But you basically create a rule. Let me show you the actual slides. So you create a rule. That rule is basically just like a little tiny function that runs right when that user logs in that says, okay, basically attach this to the JSON Web Token. So you can attach any custom information you want to that JSON Web Token. Just know that there's a slight caveat with that. where if your JSON Web Token is too large, you could run into problems, like performance problems in particular. And depending on how you're using it, it could be too large for certain requests. But yeah, so that's kind of like the setup of the Auth0 client. Super straightforward. Once you've done that, you basically take the Auth0 client ID and the Auth0 domain and plug it into the front end and the back end. And I'll show you guys how that works. So let's actually look at some code. Let's see. Okay, so in the actual project, I don't know if I can zoom in on this anymore. Let me see if I can do this. There we go. So basically, there's a backend and a front end folder in this project. The backend is the actual service that gets deployed to AWS. All the functions and what have you, and we'll walk through that in a second. And then the front end is obviously just the React app. Pretty straightforward. But basically, the way that I've set it up is you plug in your Auth0 client ID and domain right here, and that's used in the actual like authorization. The Auth0 client uses those values when it connects, when a user clicks the login. So that's how that's hooked up on the client side. Both of these values, like there's nothing sensitive about them. So you're totally cool doing this. Never, ever, ever put in a client secret into your front end code. That could be bad news bears for, for your company. Okay, so that's the front end application, how you hook that up. And then on the back end side, similarly, I have an example here. I don't know if that's a real key. Oops, I'm gonna need to change that. Okay, clicked on the wrong file, but that's cool. Basically in the config, what we have is the only thing that's sensitive here is actually the SendGrid key. But basically, the Auth0 domain, that's used in the actual function code. Let's take a look at the actual, like what let's see here. This is what the actual custom authorizer looks like for Lambda. And we'll just like walk through this code. So really the only value that I actually need is my Auth0 domain, because there is an Auth0 client that grabs the JSON web key set, which if you don't know what that is, don't worry. It's kind of confusing, but basically it will grab keys and like decode them. And yeah, but basically, so you call into this client with this, the function is just saying like, hey, make sure that they have an authorization token. If not, call back with an error. Then grab the actual JWT out of the request. If there's no auth token, call back. Then let's try to actually decode the token so that if the JWT is malformed, we want to exit early and not do any like API requests. And then we, if the token's empty, then we'll call back. Then we grab the actual KID out of the decoded token, and then get the signing key from Auth0. So this is where like all the security stuff is happening. And then we're getting back the public key from Auth0. And then we are going ahead and getting, and once we have that key, we can actually verify that the auth token is signed by Auth0 or whatever our provider is. If it's not, then it'll call back unauthorized. If it is, then it will go ahead and generate that IAM policy. And that's what I was talking about before. You can add as much logic as you want to this function. You probably want to keep it as slim as possible. But for instance, like here's an example of like, I only want to let through people that have verified their email. So in their JWT, if their email is verified, let them through. Yeah. So cool. So that's the authorizer function. Let me go back to my slides. Oh yeah. And then there's, yeah. So you actually deploy this service up to the cloud. You would use, so it's using the serverless framework under the hood, which if you're not familiar with the serverless framework, that's the open source kind of deploy tool that we have. Highly recommend checking out the docs. It has like, whatever your given cloud provider of choice is, what you want to use in there. But yeah, basically with the backend service, I would just CD into the backend, CD backend, and let me just go ahead and 1 second. I need to fix a key. Okay. We'll close that. Actually, just deploy this service. All I need to do is SLS deploy. I believe I need to provide it with a stage. Let me see. No, I don't. So if you don't have serverless installed, you npm i serverless-g. If you do have it installed, you can just type in serverless deploy, or SLS deploy for short. But basically what that'll do is it will bundle up your code and zip everything up and actually wire together all of those disparate pieces that I was talking about. So you don't necessarily need to use a framework to do this. You could write like raw CloudFormation. It's pretty intense if you do it that way, though. And what I mean by that is, I'll show you guys the. So you actually have to. So like this is the CloudFormation that like the serverless.yaml config gets compiled down to. It's like pretty verbose and actually hard to kind of reason about. It's probably like 900 or more than that lines long. So what the like CloudFormation or what the serverless framework actually is doing is saying like, okay, take just, I've defined some functions. So I've defined a custom authorizer function. I've defined, handle form entries, get form entries, etc. And I'm exposing these at a given endpoint. And what the framework does under the hood is it will wire everything together. And because these are attached to an HTTP event, it will actually wire that up inside of API Gateway for you, aka writing, that couple thousand line CloudFormation template. Also will set up all of the IAM permissions needed for API Gateway to talk to your Lambda functions, etc. If you do this via the AWS UI, it's not very straightforward. And if you're building multiple services, multiple microservices, it gets very kind of unmaintainable very quickly. So that is that's kind of why the framework exists in the first place. That said, there's a lot of different options out there. Choose what's right for you. We don't make money off of the open source framework. It's just a tool that we built because we needed it. Our kind of business model is more around auxiliary tooling you might need in the serverless kind of ecosystem. And the framework will always be free. People always ask, like, are you going to charge me for it one day? And no, it's not. It's open source. And yeah. But cool. So I've deployed that application, and let's take a look. So it ran through, updated my CloudFormation. I didn't change anything, but it comes back and it says like all the information about my service. So we can see here that there's these are the endpoints that are exposed. So these are the actual values that you plug into your front end UI and say like, okay, handle form entries, get form. These are the admin ones that have like custom authorizers actually, and the functions that are listed inside of your service. So the way that these are protected, the get form entries, the update form settings, and the get forms, that's actually defined in the serverless.yaml. So this is the public one, where basically there's no authorizer on it. But this one, like, we for sure want to protect. So like really all we need to do is add an authorizer key here. And it's referencing, this auth is referencing this function right here. And that's the function that I just showed you guys previously. That logic that checks the JWT, etc. So basically, before get form entries gets run, this auth function gets run. And if it succeeds, then it'll go ahead and call this. If it fails, it will go ahead and exit and say you're not allowed. That's really how it works in a nutshell. Inside of serverless.yaml, there's some other kind of bits and pieces in here. This one's a little more complex to look at, but let me create a really simple one. So if we go, let me just make a directory. Hi. So with the framework, I can just do serverless create, and there's some pre-made templates in there. I'm just going to use the hello world one. It'll go ahead and scaffold out a project for me. And if we look at this code, super simple. Like this is just node code. Like you can use any npm module from the ecosystem. Just npm install it into your project, and require it in, and go nuts. And then the serverless.yaml, this is way kind of simpler to look at as a simpler service. But basically, we have the name of the service, we have where it actually is run, and we have like what functions it actually has. So this just has one function. It runs this code. So the handler file, inside of the handler file, there's a named export of hello world. That is what this is referencing right here. And then so I could deploy that just as it is, and I can invoke this Lambda function with like the AWS SDK if I wanted to. But what I can do is actually expose all the functions to events. So this is just like basically putting an HTTP endpoint on top of this function. There are a lot of different events that you can actually attach things to. So those are some of like the use cases I was talking about. So you could set it up a function to run on a cron. You can set up a function to respond to new items added to Dynamo table entries. You can respond to SNS queue messages. You can respond to what else? Kinesis. You can respond to Alexa skills. Like there's a huge list of the events that you can actually respond to. And that's kind of the idea of that event-driven design approach. So in my actual architecture, what I could do is, if I wanted to expand this functionality further, for example, I could actually attach a listener to this Dynamo table and say every single time that there is a new entry added into the entries table, I want you to trigger a Lambda function. And that's what's called a Dynamo stream. But basically like, hey, a new form has been added to or a new entry has been added to the entries database. So basically trigger a Lambda function that notifies sales that this person just filled out the form. So like it kind of opens the world on like what you can do, where like before you kind of needed to write that logic yourself. And maybe poll a database, but this is event driven, where it's like every time there's something added to the database or deleted or modified, like you can listen to that and then trigger a function to handle it appropriately, or trigger a function to route it wherever you want. And it gets really, really powerful pretty quickly. But yeah, so let's see. I just kind of talked about this. I'll just go through one more time real quickly. So the serverless.yaml is basically saying like, yeah, where do I want this thing to run? The provider in our case is AWS, and the runtime. So AWS supports a number of different runtimes like Python, Node.js. They just announced Go. You can shim other languages that they might not support yet, and they also support Java, and they actually support Node 6.10 now. And I wouldn't be surprised if they support Node 8 very soon. But yeah. So if I wanted to deploy this to Google, for example, I could just change the provider name to Google and deploy that up as long as I have my Google account credentials set up on my machine or in my CI/CD system, it could then deploy, the functions to that cloud instead. And then, yeah, like I mentioned, we have our functions block where it's like, hey, I want to save a user, like trigger save user. So like this code, what to run, handler dot save user. And I want it to run when a post request hits /save user of whatever this endpoint actually is. And you can add custom domains on top of endpoints, of course. Yeah. And like I mentioned, that save user is just a name that export from the code. This is just straight up node code. I am using the AWS SDK to connect to Dynamo. But yeah, it's just putting something into my doggy dating app. It's something I'm working on the weekends. I think it's going to be big. We'll see. Okay. And then, like I mentioned, and what we saw was like, yeah, in the current working directory where the serverless.yaml file is, you just go ahead and deploy that. It will then go ahead, package everything up, and deploy that and return any live endpoints or like service information that you might want to do something else with. But yeah, so there are a ton of things that we use it for on our site. This is actually a super old picture of the site. We have a new one now, but we're using it for all of our web forms. We're using it for custom APIs. You could use it for automatic thumbnail generation. That's one of the biggest like examples out there. Kind of trivial. You can do a lot of more complex things. New user welcome emails. So we're using that actually for new people that sign up on forums. It triggers a Lambda function. Lead revisit notifications, showing related content on the blog if you wanted to. And then, yeah, doc feedback is an example. Like, was this content helpful? Yes or no? Right now, we're using it for 404 tracking, and we actually can proxy out to a given path that this is something that Netlify gives you, that you can basically run a Lambda function like on like a sub path of your site to return HTML. So a Lambda function doesn't need to return JSON. You can return any binary format you want, including HTML. So you can actually do React server-side rendering through a Lambda function. But yeah, and real quick, I just mentioned Netlify. Let me show you what that actually looks like. What does this say? Yes. So with Netlify, like honestly, all you need to do is, and this is how you deploy the front end of this application. If you sign up for a free Netlify account, these guys, I don't know how it's still free for most things. Anyways, I think they raised a bunch of money, but they're killing it. So if you connect to Netlify, you just OAuth with GitHub, choose a repo. So you could choose this forms repo. Then you just give it a build command. So in our case, we're changing directories into the front end one. Then we're running npm install for our dependencies. Then we're running the build. And then that outputs to a build folder. This will automatically publish. This is basically our CI/CD pipeline for almost all of our applications, really. This demo one as well. But it's super straightforward to do that. But yeah, some of the benefits, like you get automatic branch previews, which is amazing. So like if you wanted to show, the marketing team a new feature or the product team a new feature, or like actually A/B test a feature, that you could do that with branches. So every time you do a PR, it will publish a unique URL like subdomain, and you can send that to whoever to go check out the new feature, for example. That is like hugely powerful and not trivial to do on your own. That alone is like well worth using Netlify for static hosting. You can do redirects. So like out of the box, you get redirects by just adding a redirects file. This is hugely like hard to do, at least in my experience, with other kind of static hosts or like using GitHub pages. You can also proxy URLs. So like I mentioned, like on my site /directory star, like that, instead of hitting your static site, can just ping a Lambda function and return back any dynamically generated content based off the path after that. So like you could literally, you know, expand your site to an infinite number without it having to literally be in the static build. Very awesome, super cheap, amazing support. Love those guys. Highly recommend them if you can't tell already. And they pay me to say this. I'm just kidding. They don't. It's yeah. Yeah, that's like Netlify. Anyways, how we Jason, how are we doing on time? I don't know. It's ping me on Skype if we're going over. I just want to show you guys a couple more like example architectures. This one we're actually using for a product that we're building. So if there are any GraphQL fans in the audience, you can use GraphQL inside of a Lambda function, write all your resolvers. Those resolvers can go ahead and you know, fan out to wherever the data is coming from. This diagram is simply showing you know, calling into Lambda functions, but we do have a Apollo serverless project that might interest you if you are a GraphQL aficionado. Let me show you guys that real quick. So this is using the Apollo client, but it's like basically showing an example of like fanning out to like Elasticsearch, API Gateway, DynamoDB, Postgres, MySQL, Neptune, and GraphQL. Like this thing is pretty crazy in a good way. Yeah, so I recommend checking that out if you're interested. The other kind of pattern that I wanted to show you, which we've already seen this. I gotta remove this slide. So again, check out the real world use case. I show a lot more example diagrams in there just to give you kind of some context of the types of systems you can build with this and the cost savings associated with that. This is a blog post. It's on Medium. It's by Yan Choi. I don't know if I'm pronouncing that right. It's amazing. They built an entire social network on serverless architecture. It looks a little crazy just to look at it first, but these are all kind of built with bounded contexts and like a microservice kind of driven approach. And then there's like message passing with different queues and what have you. So you can build pretty robust systems. And again, like these Lambda functions, so all the orange little boxes, you're not paying for those unless they're being run. So you are saving basically on costs there, especially if your service is not being used. Another resource to check out, just if you are curious, like what maybe like how much you possibly could save. This is a project by IOPipes. They do like monitoring and logging for Lambdas and perhaps other providers now. But it's servers.lol. It's a pricing calculator. There is a tipping point where it might actually be better to run in EC2 depending on your load and how spotty traffic is. So this kind of helps dive through that. But typically, you know, getting off the ground and running with like a serverless project and Lambda functions is vastly simpler in my opinion. And if you did run into the instance where you did need to switch over, you know, all your code and logic is, you know, written in Node, so you could port it over pretty easily. Cool. Awesome. And then, yeah, I've already mentioned the serverless examples repository, a ton of the different use cases that I mentioned, including like using custom authorizers, how to encrypt environment variables, how to, you know, talk to DynamoDB, how to set up SNS queues, etc. Yeah, tons of stuff in there. And then the other tip, if you search GitHub globally for .serverless, that's what you git ignore because it's like your cloud formation you don't want to commit. You can find a lot of different examples out in the wild. a lot of production kind of grade serverless apps out there. Cool. So yeah, that I'm almost done. There's one last thing I wanted to show you guys. And that is, so we've been working for some time now on some new things to the framework. If you're an existing user or you're building things in the cloud and you're interested in kind of like jumping into the serverless space, I'm looking for beta testers for basically some new additions to our open source project, the framework. And I'll give you guys a quick demo. I was on the fence, but basically what it does, if you're familiar with the framework, this is actually a prototype. So I'm going to add this to this forms project, but basically like it adds a couple new features to the serverless framework, where basically you can configure your service very, very easily and share this. So if I just ran, so node index.js is running like the actual CLI tool. So this would be like serverless config, but if I run config, I can, it will read my config file for any parameters that it needs that are required. And then I can go ahead and like fill those out and step through them one by one. And then after that, basically I can deploy that. The other kind of added kind of feature, just to preview real quick, is kind of a, so this, I have an example service. Let me actually go to this repository. So right now, like when you deploy something with the serverless framework, it goes into given the provider key that you give it, it will provision the functions that you specified, as well as any of the resources that you specify. So down in the resources section, this is like CloudFormation for the actual tables that I'm using, the Dynamo tables. So I can provision stuff inside of AWS, but kind of what I've been working on, and I really want some beta testers. So again, that URL is SLS beta test if you're interested or have ideas on this. But what this kind of current limitation of the framework is like, I can only deploy resources to AWS with this kind of setup. So we're working on a way to basically like let you be able to define any type of infrastructure as code. So be it, you know, if you want to use Terraform with serverless, if you want to use, you know, automate setting up a Netlify domain, if you want to, for example, set up automate GitHub webhook creation and configuring to your functions, etc. That's actually the demo I want to show you guys. So let me go into a repo. And then this is the last thing, and then we'll open it up for questions. I feel like there's a lot of questions. Okay. So this is an open source workshop. This actually has like a ton of different use cases and kind of the core concepts of the framework. So if you are interested, I highly recommend checking it out. Or you know, if you want me to come teach, let me know. But as well as like basically all the different event types. So connecting to Dynamo streams, Kinesis, S3 triggers. Yeah, step functions, etc. But what I want to show you guys is I'm going to deploy a service that automatically configures a webhook to a GitHub repository. So what we could see here is no webhook in my repository. I'm going to go ahead and deploy this. It is going to go ahead and take my config values and set them to the service. These are defined per stage. So dev, prod, QA, or if you have custom stages, that's a concept that I don't really touch on. But the idea here is like when you define your infrastructure as code, you can deploy it into multiple stages or in an integration testing environment to like random stages. and then tear them down after the fact. But yeah, so this is going to go ahead and create a stack for us. It's going to take a little bit. This is one kind of caveat with using CloudFormation under the hood. It does take a little bit of time setting up the initial IAM policies. And just to kind of show you what that's doing. So like the CloudFormation template is generating a stack inside of our AWS account. Let me actually pull up AWS and show you. So inside of here, this app actually, I didn't show you guys the YAML. Let me show you that real quick. This app is actually, it's called Overbearing Ops, just the demo. And what it does is it sends a text message to somebody every time there's a push notification to a GitHub repo. But yeah, basically it is updating the stack, creating all of the resources, including that third-party external resource, which is that GitHub webhook. Cool. So that's actually done. It's returned back like our values, etc. Let's go look at that repository. So if I go ahead and refresh the page, there is the GitHub webhook, and it is responding to push events. So before you had to kind of wire this together yourself or write your own scripts, etc. But this kind of new concept is, just defining you want a GitHub webhook in your service and what function triggers it based off what GitHub webhook event, which there's a ton of them. If you've ever set up any webhooks, this is, yeah, just doing everything right now. But if I could choose, yeah, there's a bunch of different ones. So anyways, that's kind of the demo. And what this gives you as well is a way to, if I, let's say I'm destroying my service and I want to do cleanup, the beauty of defining your infrastructure as code is it knows how to update. It knows how to create all of the resources for you. It knows how to update all of the resources for you if you change the configuration of them. So if I change like the GitHub repo, for example, or if I changed, instead of listening to push events, I want to listen to GitHub star events, it would know how to update the third-party resource as well as cleaning up. So I'm deleting this stack right now, and we can see in CloudFormation it's deleting. The deletion is in progress, and it will go ahead and clean everything up. So while that's going, I feel like it's time for Q&A. I've been talking a while. I just looked at the clock. But yeah, so if you are interested in something like this, yeah, let me know. Check out this URL. I think it's cool. So anyways, cool. So yeah, with that, we'll open it up for questions while that stack is deleting. So I'm going to answer this. Hello.
We just finished. Oh, good. You're still talking. There we go.
Cool. All right, so that was a lot. Was that too much? Cool. So how do we want to do this? Q&A.
Yeah, YouTube's still running. It's looping the audio every 10 seconds.
Okay. Let me. All right. I'm gonna stop the YouTube broadcast. Sorry, folks watching. This is for Portland eyes only. I will respond to the other people in chat though later.